This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Giovanni Asproni, and today I will be discussing refactoring from Java to Kotlin with Duncan McGregor and Nat Pryce. Duncan has been a professional software developer for over 30 years. He was an early adopter of object-oriented programming, extreme programming, and more recently, functional programming in Kotlin. He co-authored Java to Kotlin, a refactoring guidebook, and publishes a weekly YouTube video on Kotlin. Nat has been developing software for many years in various languages, platforms, application domains, and industries, and he's a co-author of Java to Kotlin with Duncan, and also co-author of Growing Object-Oriented Software Guided by Tests with Steve Freeman. Duncan and Nat, welcome to Software Engineering Radio. Is there anything I missed that you'd like to add?
No, I think that was very good.
Hello. Lovely to meet you.
And before we start with the questions, there are a few episodes related to this one. There is episode 666, Eran Yahab on the Tab 9 AI Coding Assistant, episode 656, Yvette Ordog on Rewrite versus Refactor, and episode 326, Dmitry Jamerov and Svetlana Izakova on the Kotlin programming language. Okay, then let's start with the questions. Now, what considerations should the teams make to decide if they want to refactor from Java to Kotlin? I mean, from a technical perspective.
Well, I think technically, just do it. I mean, there's nothing, if you're, certainly in the Java space, there is nothing stopping you using Kotlin if you are developing Java. It is as lightweight as Java is, which is to say, not terribly lightweight, but it doesn't add any weight to a Java program, really. And so if you like the look of the thing, go ahead, try it out.
One of the benefits, I think, compared to a lot of other alternative languages on the JVM, is that JetBrains, who wrote it, really put a lot of effort into how you can gradually adopt it into an existing Java code base. So you can add it to the build, and that doesn't change. Your Java will continue to compile just fine. You can then write little bits of Kotlin, and you have almost seamless interop between Kotlin and Java. So there is no interop layer that you have to write. The sort of code looks exactly the same on either side of the language barrier. Kotlin has more type safety around things like nullability, and Java doesn't. So in that interop layer, the compiler will put in null check so that you get, if there is a null going from Java to some Kotlin code where you said this will never be null, it gets caught as it passes through the interop layer. So, you can gradually increase the type safety of your code base bit by bit and slowly spread that outwards, increasing the area of your code that is now Kotlin until you have no Java left at all, if that's as far as you want to go, in small steps, which is why we called the book, Refactoring to Kotlin. It's not about a big bang conversion. It's about gradually and safely transforming the code, improving it by introducing Kotlin into existing code.
Kotlin is terser than Java, I think. And if you like the verbosity of Java, you may not like Kotlin because of that. You can leave types out of Kotlin, you can put them in, but by default, it tends to be less cluttered, should we say.
It has type inference. So you don't need to declare types as much as you do in Java, but they're still there. They're still being type checked. The type checker it works better than that of Java. It has better ergonomics. And so, yes, it's not like the types aren't there. In fact, you lean much more on types, and you can do in Kotlin because the types are so much more convenient and get out of your way. So you can apply much more type level modeling, and you use reflection much less, to the degree that, the Kotlin reflection library is an optional library. It's not just part of the standard library. You have to choose to bring it in. And so the default sort of style of Kotlin is more compositional, more statically bound, more statically type checked. And you can use that to your advantage. That's the way that you like to design. And it takes a while to adapt to that if you're a Java team, because it is different than the typical way that enterprise Java is written.
And you've done, just to clarify with our audience, you've done this refactoring from Java to Kotlin in reality as well. It's not simply talking about something that would be nice or... Yeah.
No, we've done it a few times. And so have other teams we work with. So we adopted Kotlin when we were both working in a scientific publisher. We struggled with doing functional programming in Java. We looked around for alternative languages, and Kotlin seemed to be the most commercially viable. This was before Google adopted it for Android. So that happened about the time that we took our system to production, which was, we were writing experimental systems, and then one of them needed to go to production, and bing, Google adopted Kotlin as the official language for Android. And we were like, whew, that was lucky. We didn't have to rewrite the whole thing in Java. And so we just upped the version number in our build file to 1.0 and into production it went. But then we used it, I think then I was on a different project. We had a strong steer to go Java, but eventually the team just put Kotlin into the build and started changing some of the internal domain model classes into Kotlin. On that project, we had a strong inclination towards functional style, immutable domain models and things. So we were able to remove hundreds of lines of code per domain model class by adopting Kotlin, because it has natural support in the language for immutable data classes, easy transformations and things like that. Not as powerful as something like Scala, right? But the organization didn't like Scala, had been burnt by it in a couple of projects. And so this was like a nice, happy medium between Java. It's very approachable for Java. There's no sort of new ways of thinking about design, really. You can use immutable data and transformation and data-oriented programming, but you're not writing monad transformer stacks or anything like that, right? So it's very approachable for Java programmers and provide that smooth path where you can gradually introduce it into a code base and introduce stronger type safety and push that further and further out through the code bases as you work.
Okay, and so now that you mentioned that, can you give us a brief overview of the similarities and differences with Java? But you already mentioned some of them. I think maybe something else.
I think the language has a different feel. It feels tighter, it feels better designed, it feels more modern. In terms of the actual capabilities, I don't think there's anything that you can do in Kotlin that you couldn't do in Java. And Java, in fact, I think is caught up really quite well. Java now has record types and things that Kotlin introduced and simply weren't available in Java at the time. I think Kotlin program is probably a little more functional than Java developers. Kotlin's type system, as Nat said, I think is better designed, especially with respect to generics. So you do a lot less declaring that this is question mark super T and whatever the other one is. And another couple of features. One, Kotlin has the idea of inline functions where you can ask the compiler for the type that this is actually being invoked with.
As rarefied types.
Yes. Rarefied types. And those in particular, I think they're sort of poor man's macros in some sort of way, but they lead to an awful lot less reflection in Kotlin and effectively allow you to write your own control structures and things like that. So you can write functions that take lambdas that you can return out of and those sort of things.
I think that's the one difference really between Java, right? There's the one thing that you can do in Kotlin that you cannot do in Java is the inline functions, because it allows you to write your own control structures.
That also plays quite nicely into generics because inline functions don't end up boxing primitives. And so that probably one other thing that Kotlin can do that Java can't.
Yeah, so Kotlin doesn't distinguish between primitive and reference types like Java does. It automatically, and at the interop layer will automatically, if you have a Kotlin int, it will pass it in as a Java int or a Java integer as necessary and does its best to hide that from you entirely. It has non-nullable types in the type system. So every type you can mark is by default non-nullable, and you have to explicitly say whether you want something to be nullable. So that is something that Java type system doesn't do and has been on the cards for a long time. Can't remember what it is, Project Valhalla, is it? But it's going to be a long time before we get that. But it is, to the Java developers that were adopting Kotlin and refactoring their code to Kotlin, that was a massive selling point. They could just lean on the compiler to track nullability, and even the annotations that Java has for stating whether something null or non-null. They can't apply in all the places. You can't apply them to a generic parameter, for example. So you can't say, I've got a non-null list of nullable values. It's just not something you can express in Java, but it naturally falls out of the Kotlin type system.
Okay. Yeah, that is quite an interesting one, because removing nullability in many situations actually removes an entire class of errors and checks as well.
It's almost like, I compare it to the first time I used a language with a garbage collector. There's a sort of freedom you get straight away from not managing your own memory. And you go, that's nice. And I'm instantly X% more productive, where I think maybe with a garbage collector, the answer is 100. Nullable and non-nullable types is, again, that sort of freeing thing. So all of a sudden you go, I really wish I'd had this for the last 10 years of my career.
Yeah. Yeah. But also, you mentioned before that Kotlin tends to be programmers that work in Kotlin tend to be a bit more functional in style. So maybe explain a little bit to some of our audience. There's main differences or similarities between functional and object-oriented programming.
I would say, I'm going to start because Nat's the computer scientist. So from the non-computer scientist side, it is largely about how we manage state. And so state, in particular, changing state, is the problem we have with software. Something changes some other thing. Which pieces of our program can see that change? Which pieces of our program can't see that change? Is that a valid state change? Those sort of questions. Object-oriented programming said we will encapsulate state inside objects, and those objects will manage state change within them. And functional programming says, let's manage state change by having immutable data and then copying that mutable data, making changes in copies, and then managing the visibility of which version of a particular state we're looking at. How's that, Nat?
I think that you get more explicit data flow, right? Because you don't have mutable state causing changes in other parts of the system through aliasing, you end up having to feed that state through function parameters and through expressions. And as a result, what I find is it's easier to come to a code base, understand what's going on, understand how one piece of that code base affects another piece of the code base, which can be a real challenge in large frameworks, especially when they are designed with reflection and AOP and things like that, which make the composition very difficult to immediately understand. So you have explicit composition, which can reason about behavior of your application through manipulating the syntax of your source code, and not by having to simulate the running of the program in your head in order to understand what effect any change to that source code will have. See what I mean? So that makes it much easier to make changes more rapidly and more confidently. You
mentioned also, there's some terminology around this. When you talk about functional programming, you mention also effects, actions, calculations. Can you give us a bit of a definition for what this means?
Actions and calculations is a thing that I do bang on about. And the idea that we can divide our code into two types of things. If it doesn't matter whether or when we run a piece of code, if the result of calling a function is only ever determined by the values of the parameters we pass into it, then it's a calculation. And in functional programming terms, it has no side effects. It is referentially transparent. But I like the term calculation. Everything that isn't a calculation is an action. And that means that it matters when we call it. So anything that involves I/O is an action, because if we read, we may be reading different things at different times. If we write, it matters that we actually write. Random numbers, time, those sort of things are actions. But it does help a great deal if we divide our programs up into the bits that are actions and the bits that are calculations.
And a concept that I actually quite like, that I find really interesting that you mentioned in the book, is you talk about the grain of a language.
Yeah, it's something that somebody wrote on the C2 wiki way back. That's where I got the term from. And the metaphor is like wood. Wood has a grain, and a carpenter will know that certain things are easier along the grain and certain things are easier across the grain. But the grain of the wood, if you're not aware of it, you'll be working too hard. when you're trying to do something, or damaging the word or damaging your tools. So languages are the same. The designer of the language has made some deliberate choices to make some things easy and some things deliberately not easy, to sort of nudge the people using the language to write code in a certain, towards a certain style of design. And then around that, people build libraries and tools, and they bed in that grain and affect it. And there's a feedback loop that the more libraries you get that work a certain way, the more code you write that matches that. And eventually there's a certain way of writing code, right? So Java, most people write Java now using the Spring framework. That's lots of annotations, lots of reflection. Java doesn't have to be written that way, but it is written that way because of the amount of code that has built up over time. And because of Spring was a really good approach to working with the J2EE frameworks back in the early 2000s, solved a lot of problems in those frameworks. Those frameworks have sort of gone now, but we still have Spring and we still have that way of coding. Kotlin has made deliberate decisions to be different. It pushes you towards strongly typed and immutable data. It makes it easy to work with immutable data. You have to choose whether your data is immutable or mutable, and it's as easy to make it immutable as not, because the standard library also comes with a very rich collection of higher order functions over collections for transformation, folds, zips, maps, all of that stuff is at your fingertips and much more easy to use than Java Stream. So you reach for it more naturally. The default is to have data that's not nullable because it's more effort to make it nullable. So you tend to be modeling nullability very deliberately and in small places and not all over the place, things like that.
I think maybe collections are the place that it's easiest to see, first of all, the difference in the grain of the language. Java collections from the outset were mutable, and that was acceptable in the 90s. These days, immutable collections are more the fashion, and Kotlin collections, the default Kotlin collections are immutable. Now, they're actually implemented with the Java mutable collections, and so there's no difference like implementation, and because of that, they're very interoperable. But if you start from a Kotlin collection, you can't add items to it. And that gets you in the frame of, okay, well, if data is immutable, what do? Well, I have to work with a collection that is a copy of this one plus these other three items, or a copy of this one with these items transformed in this sort of way.
So let's see. So something like immutability, in terms of immutability in collections, for example, goes well with the grain of Kotlin, but in Java is a bit more problematic. But is there an example of the other way around, like something that is actually easier in Java that goes with the grain of the language in Java, but with Kotlin is a bit more problematic? I don't know. It doesn't have to be, but I'm asking if it is the case.
In Kotlin language, and very minimal support in the standard library for that amount of reflection. So you can get a class, you can get a function. So if I've got a function, I can turn that function into an object that happens to have a function type. I can refer to a property and get back a property object where I can ask for its name, but it's all strongly typed at this point. I've never escaped. I'm not doing reflection as in Java, where I can ask for a class and say, give me the thing with that name. And then I have to use untyped data from that point on to interact with it. Kotlin gives you enough reflection to have things with names or wrap them in laziness or whatever, but not enough that you are out of the type safety. So in that respect, full-blown reflection is easier in Java, but I don't miss it because of the grain of the language. It's not something you really turn to very often.
Yeah, and I guess using reflection also makes understandability of the code a bit more difficult in many situations, because it's not simply reading the code, it's like what is doing behind the scenes that you don't fully see there. Okay, let's now go maybe to a bit more into the mechanics of the refactoring from Java to Kotlin. Now, the first question is, in the context of moving from Java to Kotlin, how do you distinguish between what is a refactoring and a rewrite?
We had quite a discussion about that with our editor when we wrote the book. So we called it a refactoring guidebook. Originally, we wanted to call the book Refactoring to Kotlin because Kotlin's big benefit compared to most other non-Java languages on the JVM is how seamlessly it interoperates with Java, how gradually you can introduce it into the code base, and how little work. There is no interop layer, really. The compiler does all the work for you. If you add Kotlin to your build, you've still got a Java program, but you've got the option to write some of it in Kotlin. You can go and add a little bit of Kotlin, and Java can call it as if it's Java. Kotlin can call back to the Java. It's just another class in your compiled program. The compiler works out, based on the dependencies between the Kotlin and Java code, how to compile it so that it compiles correctly. It's not like you can, I must compile my Java and now I can compile my Kotlin depending on the Java. It just works it out for you. And then one of the greatest features, is written by JetBrains, IDE vendor, is the magic key press to take that Java and turn it into Kotlin, right? Just one key press transforms the file into Kotlin, gives you a few options like, do you want me to make it so that I change all the Java to sort of match your Kotlin? Or do you want to annotate your Kotlin so that you don't have a very big impact on your Java code? And that kind of thing is really great. They really thought about, as you're transforming a large code base, you're not going to rewrite it. You can't rewrite it. No one's going to say you can't do any more business development while you're converting into Kotlin. Right? You can introduce it, and other people are working in this code base. They might be calling into the code that you're currently turning into Kotlin. With a single key press, you can do that and not impact their work. And then as that code that's depending on what you've changed becomes Kotlin, you can remove these compatibility annotations, and then everything becomes much more natively Kotlin. So I've never really done a lot of multi-language development, and the interop layer has always been painful, right? We've written J and I between Java and C, or between Python and C, or TCL and C. I show my age. But yeah, it's always been a painful experience. And with Kotlin and Java, it's incredibly easy.
I think the grain here is maybe pertinent as well, because the interop is completely seamless. You literally can just take one file from the middle of your Java program, convert it to Kotlin, and it will continue to work. Everything will be fine. But the grain of Java and Kotlin are different. And so if you're a Java programmer who thinks a little bit more functionally, then your Java code will naturally convert to Kotlin, more idiomatic Kotlin, say. So I think the danger is not so much that we end up with that the interop is hard, but that the functional thinking, the change across the boundary is difficult. So that we end up with Java that's busy mutating collections and Kotlin that's assuming those collections won't be mutated.
So I would imagine that then this step is initially you can start helped by the tool, to say from Java to Kotlin. But then at some point, as you move on, probably there will be some level of redesign of the application as well. Because when you go with a grain, if you change from one language to the other, you go with a grain of the new language, this may direct you towards a different shape of your system to some levels. Am I correct?
As that little bubble of Kotlin sort of expands outwards, and in my experience, it was null safety that really drove that. So people were using the optional class in Java because they didn't want to use null pointers. But that has, awkwardness of its own. And so once the area of Kotlin had spread far enough and we could replace optionals inside it with just nullable types, then inside that code, we could start thinking more about how do we make better use of the Kotlin standard libraries. Again, tooling is fantastic. And the IDE will give you little hints saying, you could use these standard library functions here instead of doing it like this. If you've got a for loop to do a map, it can say, this would be better done with the map function, right? Or if you do, a map and a filter, it'd be like, I can do that in one, I can collapse these parts of your pipeline down into one. So when you're working in Kotlin, you learn a lot just by seeing these little brown highlights in the IDE and seeing how to improve the style to match the grain of Kotlin as you go. And it's also useful as they evolve the language and standard library. You come to open up some of your old Kotlin code and the language has moved on and it'll be, there's new little brown things telling me that I can now use new standard library features or whatever. So that aspect of tooling is great for getting people to think in a more Kotlin.
When we are talking about tooling here, we are talking specifically about the JetBrains.
Yes, yeah. So, JetBrains is an IDE vendor. This is a language that was, written with IDEs in mind, and the tooling was very good for a brand new language.
Yeah. But also, as to be said, I think the JetBrains, the IntelliJ is actually, there is the free version that everybody can use. Of course, if used for commercial purposes, the company has to pay for, but everybody can use the free version, I guess, for their own projects.
It's open source, so I think
It's open source. Okay.
I think that even companies can use the free version for commercial software development, but the enterprise edition or ultimate edition, whatever they call it, has a lot of enterprise software support. So it supports databases, Spring, and all of these other sort of enterprise things.
Doesn't add much to the support of Kotlin itself.
It doesn't add anything to the support of Kotlin. All the support for Kotlin is in the free version.
Yeah. So basically, if people want to use Kotlin, they don't have to buy anything. They just download.
Yeah.
And I was asking this because I know. Well, I was asking this because there are many developers, for example, that seem to use nowadays Visual Studio Code. And I don't think Visual Studio Code has anywhere the support for Kotlin that IntelliJ has.
No, I mean, Visual Studio Code is much less capable. It's a text editor with some additional support for navigation and a little bit of support for refactoring, but it doesn't have the whole integrated development environment sort of feeling that say, JetBrains IntelliJ does.
Yeah. And talking about tools. Now, the tools you just mentioned, support from JetBrains, that support was available well before Copilot or any AI coding editor was there.
So when we started, AI tooling wasn't a thing, right? We sort of describe it as traditional refactoring tools, although even now a lot of people don't really use them. But there is a language-aware editor. The editing actions are things like extract method, move a class, move that instance method from that class onto that class, those kind of things, what JetBrains was very good at. But they do have AI agents, and we do use them. And they have AI autocomplete built in, which doesn't have to talk to an external server. It's just, completely local. So that can do really pretty good autocomplete, actually. I've been very surprised by how capable even the local autocomplete in JetBrains is. For example, I was writing some Kotlin code to generate some Lua code. And as I was writing the Lua code inside the Kotlin code to generate it, it auto-completed the Lua, but was also auto-completing the Kotlin code to generate the auto-completed Lua for me, all in one go. Wow, right? These things have come on to, almost like incredibly capable now. And that's without having to call out to a massive data center somewhere.
So these are kind of local models.
Yes.
So it should be said that the conversion from Java to Kotlin, the one built into the IDE, so you can just basically say, I've got this Java file, please replace it with a Kotlin file, that predates AI, predates LLMs, and is just a JetBrains written plain old code, basically. I think it's certainly possible to use AI to convert larger swathes of a code base, and they certainly seem to be very good at that. But the particular tools built into IntelliJ are just templates and strings, the old-fashioned way.
And graph transformation. The IDE's got a graph model or object model of the language underneath it, and then the refactory tools work on that.
Are there any things that maybe, if you have an example, would be good, that maybe when you did the first Java to Kotlin move, if there had been an AI coding assistant at the time available, would have been much simpler to do?
I think we might attempt these days to throw more of a code base at once at an AI tool and see.
I don't know. See, I think that maybe the success was because we didn't have it. We had to go in small steps. If we'd have just done, hey, LLM, convert that code base to Kotlin for me, and I'll go for a cup of tea and come back, and I've now got a Kotlin code base. We would have had a lot of reviewing to do, and reading code is harder than writing code. And B, we would have smashed over all the work of all the other people in the team who were working away, right? So what, we would have committed that and just wiped out, or forced merge conflicts onto them. But because we were working in very small steps, we were able to gradually introduce it into a code base, additional type safety and null safety and confidence and clarity that came with the code meant that we actually saw that while we were doing the conversion and continuing to write business features and evolve the code, our delivery accelerated. So we definitely saw that we were delivering faster as we converted more and more things into Kotlin. Now, that was because, I'd say, we were writing in a largely functional style, and that takes a lot of effort in Java. So adopting a language which is, where that is naturally the grain of the language means that it's much easier to do. So we were getting the benefits of it. I can't say whether if you have a very sort of object-oriented Java program, whether you would see the same benefits straight away, but I think null safety certainly gives you a lot of benefits, and you probably would worth doing it just for that, really. So that to me is the worry of LLMs. You can do massive code change. As a solo coder, they make me very productive. In a team where teams work well together, when they make small, safe changes and continually integrate them, and the smaller steps as possible, the better we can integrate together. Where an LLM can make huge changes, sweeping changes across a code base with very little effort from the point of view of the programmer. How that will change the way that we work in teams, I think, is still unknown.
Can your software engineering team plan, track, and ship faster? Monday Dev says yes. With Monday Dev, you get fully customizable workflows, AI-powered context, and integrations that work within your IDE. No more admin bottlenecks, no add-ons, no BS. Just a frictionless platform built for developers. Try for free at monday.com/dev. You'll love it.
Are there any things at which the AI tools actually are good at in terms of, in addition to everything else we do, actually improve the process of what we do, make it smoother, in your experience?
They are good at big refactorings, which are very tedious and difficult to do with the refactoring tools. Kotlin's been around a while, but its refactoring tools are still behind those of Java. And even so, there are some things that will never be able to be done by a refactoring tool. For example, I was converting Spring's annotation-based transaction management, serializable database transactions, which involves having to use the transactional annotation and a retry annotation with some code, like logic in a string in that annotation about how you're meant to do retries when the SQL layer tells you that you've got a serializability failure, right? It's not something that comes out of the box in Spring, requires a little bit of effort to do. And I wanted to turn that into programmatic transaction management using transaction template and retry template, have them composed properly, have the rules put in properly with the right models of retry, everything prompted Junie, which is JetBrains' AI coding assistant, and it just did it, right? Now, I don't think you could do that transformation from annotations and AOP and reflection to programmatic composition using traditional factoring tools. It would require manual rewriting, and even then it'd be a very slow process of like where you do baby steps and gradual transformations in some bits, and then you'd have to manually rewrite others. So there it's focused. It wouldn't have had a massive impact across the code base with other people. It was a solo project, and it was very impressive about how well it did it.
Okay, that's interesting. So basically, there is definitely a place for these tools, and they can be used to great advantage.
I think so, yeah. And also, still refactoring tools are going to be useful because LLMs are trained on code they find on the internet. It's not the way I like to code. And I think every programmer in the world has the same opinion, right? I mean, different from my opinion, but the code on the internet is never good enough, right? So you use an LLM, it generates code, and then you have to refactor it so that the next time you use it, it generates code that's more in your style, more consistent with the code base. And over time, the LLMs become much more efficient to use, but you've got to keep giving it that guideline. So those traditional refactoring tools, I think, will never go away because they're required to nudge the LLMs in the right direction all the time.
I think you're wrong, personally. But
what do you think, Duncan?
When we say the traditional refactoring tools will never go away, I think the traditional refactoring tools will become part of the arsenal of AI-assisted refactorings. So there are still things that we want to be digital. Maybe digital is the word, right? When we rename, if we ask an AI to rename a function, it's a best effort thing, right? It is just like it's guessing the next word still. When we ask IntelliJ to rename a function, it is finding all the places that function is being called, literally, and you can pretty much guarantee that it will do the right thing. But combining those certain things, the human designed refactorings into bigger sets of refactorings, and using those tools as tools, allowing the AI to use them as tools, I think that will really become a thing.
Yes.
I'm not sure it's there yet, but I think that will become a thing. And then we're looking, I'm interested in how we describe our larger refactorings in a language that allows an LLM to take the language about how we want to transform the software and then translate that into a language of, well, I need to then pull this method up, rename it to something, and then move it into this other place. And I don't think we had that language. There are a few books on this sort of advanced refactoring, ours amongst them, I think. But at the moment, AIs are not making use of tools in order to chain a bunch of refactorings together in order to achieve a goal. And in fact, I'm not sure they even know what the goal is, but I think maybe they can get there.
Yeah. LLMs work on text, right? And so they work on the outcome. They just change the code and see what happens. And then, so if I say, make this programmatic, not annotation based, generate some programmatic stuff, tests will start failing, compiler starts failing. From those failures in the rest of the code, it kind of auto completes the next step to do and the next step to do. Amazing that this process is so effective, right? But it's still focusing on outcome and not the steps. It's not focusing on what is the right way to do this if I'm a member of a team.
Well, you say that, but I'd say that the thing about agents is that in fact we've gained the system, right? Agents gain the system by saying, yes, you can only guess the next word, but what you can do is you can guess the next word in the plan to do a thing, and then you can execute that plan. And when the plan goes wrong, you can guess the next word in, this went wrong with this error message, what should I do?
Yeah.
And then you can reform the plan, and then you can execute that plan again.
Yeah.
I think that is a really clever gaming of all I'm doing is predicting the next word. And I think we might do the same thing with languages, and we might do the same thing with systems as well. It may be that we're able to tell a system with enough memory or enough context that this isn't working because you're not taking into account your team members.
Right. I think that one effect of LLMs and their ability to refactor in the ways that they can right now is that it makes a wider variety of languages practical for professional use, for industrial use. So if I have a language that has no refactoring tools because it's niche or because Lua is a perfect example, there's no good refactoring tools for Lua. I can refactor Lua just by prompting an LLM though, right? That suddenly makes it much more practical for use in day-to-day development, where currently I just use it for hobby development. My hope is we'll see a sort of renaissance of languages. It won't just be Java, it won't just be Kotlin. We'll see LLMs allowing people to adopt a wide variety of languages, like Duncan was saying, ones which are more practical for particular parts of the system would now be much better to work with than if they were.
Okay, now let's change direction a little bit. How important are tests for refactoring purposes, especially from Java to Kotlin? How important is the presence of tests, let's say in the original, in this case, Java system, so you know that whatever you are doing works?
I mean, you're talking to TDD zealots, right? But I think both of us would probably say that tests are an economic argument. I mean, they're not the reason that we're writing code. They make writing code more enjoyable for us because we spend less time debugging. And I think we enjoy maybe expressing ourselves in tests. We enjoy the little challenges around making the TDD cycle work, driving the system in the direction that we want to drive it with our little tests. But if we don't need tests, we don't need tests.
But for refactoring, it's all about risk, isn't it? And like you say, economics. There are certain areas where I know I make mistakes, so I write tests for them. That's why I cover almost all my code with tests. And without tests, how can you do it, right? You need to know that you've not broken something. So it was one of the things that we were debating when we were starting to adopt Kotlin. Do we adopt it in our tests? Do we convert all our tests to Kotlin? first, it's low risk. It lets people learn Kotlin on something that isn't going to go into production. But in the end, we said, actually, no, we will keep the tests in Java. We'll convert them much later. We'll start by converting the domain models, because that's where we'll get the most value with the least effort from Kotlin. You won't have to integrate with Java infrastructure APIs, which are not very Kotlin friendly. And we won't have to interact with things that do a lot of reflection, like JUnit or whatever. This is where we're in full control of the model, and the model for us happens to be very close to the grain of Kotlin. So we'll get a big bang for our buck. And then as it spreads out, we'll be able to lean on it and start converting the edges of the system and the tests around those things as well.
With respect to migrating from one language to another, it's often recommended that you just try writing some tests in a new language, because that will let you know whether you like them, and you can always throw away the tests. I think that's often really bad advice, because the tests are important to a project, and maybe they're the last things you want to throw away in some ways. They do sort of represent your spec.
Another question is, are there any gotchas that developers should be aware of when they go from Java to Kotlin?
Absolutely not. It's perfect.
Interop layer, right? Like the interop layer is the main one. There are a few little places, because Java and a lot of Java libraries play fast and loose with null. You have to know what the nullability is when you call into those libraries. And there's a number of times where, even where they're annotated with like nullability annotations, they're incorrect. And Java doesn't check that at runtime, and it only gives, the IDE gives warnings at compile time or at editing time, but at runtime nulls flow through. Yeah, seems fine, right? Well, in Kotlin, as that null passes the interop layer, Kotlin will throw a null pointer exception and tell you that you've got it wrong. So that's where testing becomes very important, right? Especially if you've got a null that's going out of Java through your Kotlin back into Java again, you're not touching it, you're just carrying it through. That might be perfectly okay. But if you've taken that value, which you think is non-null, through Kotlin and out, it will be checked for null and it will fail. So that's really the main one. It's quite rare, right? And as you push your boundary further and further, you're more and more Kotlin, and you're sort of pushing it through to the edge. And now, especially, there are much more Kotlin native libraries that you can lean on. That issue becomes less and less of a worry.
I think this idea, this thing I said earlier about default immutable collections is a place that can trip you up. So if we get a collection from Java, inside our Kotlin code, we see it as an immutable collection. We may actually treat it that way, but if Java's hung on to a reference to that, it can be busy mutating that reference somewhere else.
Or worse, we pass what we think is an immutable collection into Java, and we've created that collection. Java mutates it because it sees it as an array list, for example. It adds an element to it. Boom, right? Now your seemingly immutable collection that you created in Kotlin has magically changed underneath you. Luckily, that there are very few libraries in Java that do that kind of.
Okay, but this basically is anything at the border between the two languages.
Yes, yeah. So it seems seamless. You just have to be aware that it is a seam, and there are different conventions on either side, different grain on either side, and just be aware of what the risks are. Yeah.
Okay.
It's neither seamless nor seamy. Like it's seamy, like truthy.
Let's see, from a business consideration. So when you decided that the first time you said to go from Java to Kotlin, as you said, this is a good idea to do that. But were there any business considerations you had to take into account? Maybe convincing your product managers or anybody else that this was a good idea?
I think in the original project, we were allowed to use any JVM language except Kotlin, weren't we? That was the spec.
No, I think it was the first time we used it, we were able to use anything we wanted, because they were all proof of concepts. Then the big project we started on, there we were told to use Java and not Scala, because history in that organization. But it was so much nicer that people just did it. And once it was a fait accompli, every other team pretty much in the building picked it up and started using it, because they could see the benefit as well. Just not having random failures. We did have old systems that would have regular null pointer exceptions in production, right? So that's an easy thing to talk about. You could just show the logs.
Let's say if I understand correctly, the fact that the language was so easy to introduced in a Java project allowed you to introduce that in a kind of, without making too much noises about it. Let's
Yes.
say that. And then people started to see the benefits of this move, especially because of this nullability and the immutability that gave great
And the
advantages.
concision. Yeah.
And the concision that nobody had anything against it at the end.
Yeah. Yeah. And the fact that, we're already writing Java in a very similar style to the grain that Kotlin makes easy, made it an easy win, right? Because you would replace hundreds of lines of code to do sort of functional transformations in Java with like a single data class declaration of one line.
You managed to introduce it because it was easy. So the language itself, the interoperability with Java, didn't add any overhead on the work you were doing.
I think also the organization itself was quite open to development teams trying new technologies, right? It wasn't that there was a complicated bureaucratic process to adopt a new programming language and you had to get sign off from a whole bunch of different groups and what have you. Teams were quite autonomous, right? And as long as they could, as engineers, argue the case if anyone ever asked, no one was really going into teams and telling them, don't use this or don't use that.
I think there's another important factor here, though, that is that nobody wants to down tools while they learn another programming language. And so deciding that we're going to introduce programming language X, where in order to become proficient enough in programming language X to be productive in this code base, you're going to have to go on this 2-week course, and we're going to cycle people through that 2-week course. But until everyone's been through that 2-week course, we're not going to introduce this programming language, or we are going to introduce this programming language once 4 people have been on the course, but then the other 6 people on the team can't read the code. That's a problem. In practice, I found that Java programmers basically read Kotlin from day one, and they can write Kotlin from day 2.
Okay, so in terms of skills to get started, you don't really need a lot.
No, very little.
I think that, like you were saying earlier about collections, that was the largest mind shift that I saw developers have to make. So I would see developer writing code to do a transformation, but they would have a list and I'd go, well, I'm going to write some code to take these ones out of that list. And then I'm going to write some code to put these on into the list. And now I've got the list. And I'd be, well, that's a filter followed by an addition, right? You see what I mean? And like, oh, all right, now the code is like 2 lines long. So actually the benefits of moving into that direction in terms of how short and readable the code is also are very easy to see.
The language comes also with the libraries and functions that actually help go in that direction. So I guess at the beginning, you write without the knowledge of those particular functions. Then you get to know them and your code changes, becomes more terse. And
yes.
And as Nat says, the IDE actually helps you there because there's a series of inspections where it says, you're writing it this way, but you could write it that way. And in the end, you get to say yes.
You kind of learn as you go. So somehow the whole thing is done in such a way that you learn as you go.
Yeah. And adopting the hints is also very easy because it will, like you say, it'll say, oh, you're using a for loop and mutating, but you could replace it with a map. Okay. And you just enter on that underline and boom, it's a map. So it's not like you have to sit there and go, oh gosh, how am I going to have to look up how to do a map? It will do it for you. And so the friction of moving towards that more concise and expressive way of programming is very low.
Okay. Yeah. How should the team decide where to start from? So, for example, in one of your projects, you can give us an example. You say we want to go from Java to Kotlin. How do you decide where to start? I think you hinted at that before, talking about some parts of the application where you had your models or something. But in general, what do you think the considerations there for the starting point should be?
That's right. I think we would start with data. Kotlin is very good at representing data. Perhaps if you're in a Java 21 project where we have records and those sort of things, maybe less important. And maybe if you are in a very modern version of Java, you should maybe not consider Kotlin, or at least if you moved on that far, then you must be very happy with the language you have. But Kotlin is very good at describing data.
I think it's still better at transforming data than Java is.
Yes.
So now you just mentioned modern Java. You said that if teams have gone, what version? Now is what? 2021? What is? I don't know what is the latest.
23, is it? Yeah. I mean, I just stick to the LTSs. So if it's not an LTS, I just wait for that.
So in this case, you seem to hint at the fact that if you are working with a Java that is, let's say one of the most recent ones, you might not have such a good reason to refactor to Kotlin. Did I understand correctly? Because they added some nice features in the language.
It's certainly true to say that I think Java was, what you would say, moribund when we took up Kotlin in 2017.
Yeah, I think there'd been no changes to it for 5 years or something.
Well, no, we just gained lambdas, I think, and streams and so on. But it had been a long time coming. If you're stuck on an old version of Java, and that largely also means an old version of the Java virtual machine, then Kotlin is quite an easy win. And certainly I think that's true very much in Android, which is why it's so popular on Android, that the modern versions of Java are not available in that sort of small form factor. I suppose I consider that people who are keeping up to date with Java are probably keen on the language in order to keep up to date with it. And if you're keen on the language, don't stop doing it. Java is fine, but for us, Kotlin is funner.
Yes. There are just things that are nicer, right? No worrying about primitive types. I got an int, I can put it in a list. Yeah, sure, I have to worry about performance, but I have a list of int. I don't end up with a list of integer, which is a different type, right? Things like that, right? I can have null checks in my compiler, so I don't have to think about it. I can model algebraic data types, which is now, I think, in sealed classes are now in Java. The inline functions means I can write my own control structures, and that doesn't happen a lot, but it's useful for making domain-specific languages when you want to do that kind of thing. So Java is moving in the same direction, but I think their ambitions are much greater when it comes to things like getting rid of primitive types. Kotlin wanted to get rid of them in the language, and then as a result, it will do some boxing for you, and you have to be aware of that. And if you're worrying about performance, then that's something you have to, know how to deal with. While Java are looking to remove them from the Java virtual machine. That's a much larger engineering project. No wonder it's taking so long.
Actually, that's interesting what you said now, because are there any performance implications in moving from Java to Kotlin?
It depends. It's performance, right? But so you do have to be aware of boxing. So if you've got an array of ints and then you start mapping over it, you're going to end up with an array list of boxed ints. That's going to hit your performance. So you do have to be aware. Of course, the things that Java have are still there because you're running on the JVM. Kotlin targets a number of different platforms, but let's assume that we're talking about Java to Kotlin. So you're running on the JVM. Everything you use in Java is still there. So if you want to create an array of ints, you can. So you can always drop down to, writing something specific to the JVM to manage performance. That's kind of the case you do in Java anyway. When you really worry about performance, you have to sort of make your code a certain style to avoid a lot of garbage or a lot of boxing or what have you, and work in terms of arrays of primitives if that's what matters.
The inline functions I mentioned earlier are a place where we can actually gain quite a bit of performance, I think, because it allows us to express algorithms and things on ints as well as objects. And so we won't box in those cases. Kotlin also has a feature called value classes, which are effectively types that remain as primitives, remain as just an int, for example, in the Java bytecode, but the Kotlin compiler treats as if it is actually a type. And so we can do things like non-negative int and those sort of things. And the Kotlin compiler will track the type around, but actually only ever pass around the int that is inside one of these value classes.
Because you have to worry about the interop boundary there more, but that's the case. So, I think since Java 7 maybe, Java the language and the JVM, Java is no longer just an assembly language for the JVM, right? It compiles into sometimes quite surprising structures in the JVM, which can have performance impacts, especially on embedded systems. One project we were on, we had to rummage through what was being generated on the heap by the compiler in order to squeeze more and more performance out of embedded system. And up-to-date versions of the Java, when they're using enums, generate really quite a lot of stuff we didn't want. And we had a colleague worked with the author of ProGuard to add support for sort of removing this stuff to get the performance we wanted. So yes, as we always with performance, you always get surprised by what's going on. And Java over time has become more surprising because the relationship between the Java, the language, and the JVM is sort of changing over time.
Probably because they want to support more in the JVM as well.
Yeah.
More languages, so they are changing the JVM itself to be
Yes. Yeah.
One fantastic thing from Kotlin's perspective is that JVM has gained virtual threads, and they are entirely seamlessly supported by Kotlin.
So if we summarize, this means that you shouldn't have bad performance implications unless you have some specific problems if you move from Java to Kotlin. And actually, you can have bad performances in Java as well, depending on what you are doing. So it's not like saying, if I move from C to Python, will I have performance implications? There you can more broadly say yes, in general. Yeah,
Yes,
maybe
yes.
use C libraries in your Python hotspots.
Yes.
Okay. Well, I think we are coming to the close of the show now. So thank you for the conversation. I think we did quite a good job of talking about this refactoring from Java to Kotlin. But is there
Quite a good
anything? Is there anything that we missed that you would like to add?
I just encourage people to give it a go, right? Even if you don't think you'll adopt it, it's worth having a look. You can play around with it in an existing project and see what it's like. I really like
I
it.
agree. Sometimes trying different languages, different things can give you different ideas, and maybe approach differently what you do with your language of choice.
Yes.
Okay, then we come to a close. So thank you, Duncan and Nat, for coming to the show. It's been a real pleasure. And this is Giovanni Asproni for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.